search insert position. Given a sorted array of distinct integers and a target value, return the index if the target is found. If not, return the index where it would be if it were inserted in order. You must write in log n time complexity. Okay. So I think this problem in particular doesn't, for me at least, I know that we're probably going to end up using a binary search. So binary search, we would do const middle equals target, or sorry, nums sub dot length divided by 2, and we'll do math dot floor. I guess we have to do like start equals 0, end equals nums dot length. And I will do while start is not equal to end. We're just going to put an and false here because I don't want to accidentally run it, and then we have an infinite loop. If they're equal, then we've probably figured out the index that we need to insert at, so we're going to just return start. We could also return end, but you know, they're going to be the same. This is going to be end minus start, and we could say num sub that, and we can say if middle equals target, we'll return middle. Actually, we need to do this. Else if middle is less than target, else. So in this case, middle is greater than target. It's the only option really. So I feel as though if the middle value is less than the target, that means we need to look in the we're too low, so we need to look in the right hand quadrant. So we need to say start equals middle index. Otherwise we say end equals middle index. And I think this is very close to a solution. Except for this and false. We could just run it to see if it passes the base cases. Okay, the target is 2. We hit the time limit. And the value will not be found. Okay, well. We'll set like a we'll just keep track of how many times we run. Let's say 5. And then we'll do count plus plus. And then we'll do some console logs of start, end, middle, index, middle. I'm curious if it shows an object here or something more detailed. Right, so I was saying 5's in the middle, which is 4 minus 0, 2, 0, 1, 2. Fine, yeah, I guess. And then 5 is greater than, so that means we're in the wrong quadrant. So we're gonna look from 0 to 2. 0, 1, 2, and then the middle is going to be 3. That's correct. 3 is greater than the target. So we're gonna do start is 0, end is 1. The middle index. Okay, so we get stuck in this infinite loop of not changing the start and the end. So at this point, we know that when we hit this, one is less than 2. So middle is less than target. So we are going into here. So I feel like start should be +1 then, just to handle this edge case. And look at middle. If we look at start, start is 0, start would become 1. Actually, it would be middle index +1, which would make it 2. Actually, let's think about this, because we got to make sure that the value we're getting actually makes sense. Oh yeah, the middle index is 0 at the moment. We take middle index +1, set it to start, and then it'll be 1, and 1 is the correct insert index. So we could run it again, see if we get a different result. And then this is the third test case, where we're basically going out of bounds on the right hand side. We're outputting 2. Hey Anvi, how's it going? I'm using JavaScript. Very basic vanilla JavaScript to solve the problem. Yeah, I'm looking forward to getting together with family for Thanksgiving, for Christmas. How about you? Do you celebrate Diwali? There's a chance we'll be going to the Poconos for Diwali, or for Diwali. Gosh, for Thanksgiving. There's a chance. Output. Okay, let's think about this. So the arrays 0 to 4, but I'm Okay, so somehow the middle index is 0 here. Start plus end. What am I doing? Oh, what am I? Yeah, why am I doing minus? Um, minus is not how you do an average. So I don't know why I was doing that. Oh, I see. I've not heard of bandage or Diwas? Diwa? There's a chance that we're going to the Poconos, which is like the local mountains. It's the mountains that people in this part of the US go to for decent skiing or snowboarding or general winter weather, hiking. Oh, we can clean up this code now. We good. Gotta get rid of count. Are you submitting too frequently? Okay, so, and then we can think about the complexity here. In terms of time complexity, it will be log of n, and the reason we know this is because log n happens when you're like doing a divide and conquer algorithm, which we're doing here. Every time we look at the middle, we split the problem in half. And if we find the index, that's the one we return. And if we are, depending on what section of the problem we did look at, we will switch from left to right. And if we get to the end without finding something, then we'll just say that that's where the thing needs to go. So, and then the memory complexity is big O1. We don't take up more memory based on the target or the nums. The input doesn't affect our memory requirements, just our runtime requirements. So we're gonna submit this, see where we end up. Okay, so we ran in 0 milliseconds. We hit this category of 100%, which is good. Take a look at another solution. So interestingly, they start with this concept of high, and it starts at -1, while low is less than or equal to high. So low can exceed high before we break out of this loop. They do get the mid, which we did. I'm surprised. I mean, I guess it's not faster because they don't cache this. This is also interesting. So they not only do they start at -1 of the length, they also -1 for high and +1 for low, which we didn't. We didn't have to do the -1. We only had to do the +1. And then they just return low. So a very similar solution. Just a little bit different calculations there. Let's look at a slower solution, what that might look like. Okay, so that makes sense. Literally just linearly going through the array to find the target value. They didn't really attempt to do a divide and conquer solution. So this would run in big O n. Worst case scenario. Actually, if the target is less than or equal to, I see. Do I see? I'm trying to understand why this even works. Basically, if you go through the whole array and you didn't find the element, it seems like that means it's larger than every element in the array, so return the length of the array. But if the target is less than or equal to nums, yeah, I guess that does make sense. So like as you go through the array of numbers, if you eventually find a numbers, then you will be less than or equal to it. But I would have thought that this needs to be greater than equal to. Because we want to keep going. Oh, because the number will be larger. Yes, if we're thinking about what the target is going to be larger potentially. We keep going until, oh, it's not larger or it's the same. AKA it's less than. If it's no longer larger than the element or the same as the element, then that's the index we're targeting. So, okay. I guess it's a little bit challenging. I know it's like very simple comparison, but I don't know. I wonder if it would make more sense to write this differently. I don't know. So that was that slow. This one's even slower, and my goodness. This is actually like insanely slow. This is n squared. So wow, and x equals target, x is greater x plus plus. Whoa. Interesting. It's very hard to reason. I'm surprised that this code works, just looking at it. X equals target. So we're saying we're creating a new variable storing the target number. We're gonna keep iterating until x is greater than or equal to the first number, and then we'll decrement x. We're looping over. Oh, it's got to be a while it's greater than or equal to, yeah, or for greater than or equal to. Okay, so we'll keep decrementing x, which doesn't make any real sense to me. Keep decrementing x, and then if nums index of x, which is like, this outer loop is just so pointless because you have this extra condition that x equals target, and x is only target on the first iteration. So you're just wasting time. This is actually just doing extra work for no reason. If x equals target, wow, and then they do another index of. Like, they literally have the index of already done. They do it again when they could have like cached it. So if I feel like this would also, I'm surprised this doesn't return false positives, because if like nums was, for example, 1, 2, 3, and how can we make this work? If nums was like 1 and 5 and target was 3. Oh, okay, I see how that works. Okay, it's coming to me now why they did it the way they did it. Because so I guess they aren't doing extra work, now that I understand it a little bit better. They're trying to find where we can insert this at. Right, so they're basically working from the target value and working their way backwards until they find out, oh, I can put it there. And so if basically it's actually kind of clever, but it's really complicated. And this is the thing about like clever code. It's not always the fastest, not always the best code, but it's an interesting way to solve the problem for sure. But they basically are working their way backwards from the target value to like the lowest value of nums, and trying to find the basically the biggest number in nums that's between target and that value, I guess. So basically, in my example, if it was like nums was 1 and 5 and target was 3, they would try 3 and find the index of 3. They wouldn't find it. They would try the index of 2. They wouldn't find it. They would try the index of 1 and be like, oh, index of 1 is here. I've determined that with this, but is X target? 1 is not target. Target is 3, X is 1. So we go down this one and we say that we insert at the index 2. Or the index 1, I guess, since 1 is at a different index. So very, very complicated. Basically like n squared. This has a really bad worst case scenario because it's as bad as the distance between the numbers, and that distance, the distance between the smallest number in nums and the biggest at the target, which if this is a really big number, actually it's the distance between target and the biggest number in nums, if it's even in target. So I guess, yeah, it's potentially really bad runtime if target is really, really large. If it was like 1,000,000, then this is gonna run, and nums was 1, this is gonna run 1,000,000 times. And then even if it was like 1,000,000 and then there were 5,000 elements, 1 to 5,000, this is gonna run 1,000,000 times, this is gonna run 5,000 times, this is gonna run 5,000 times, this is okay. Taking a look at this one, I'm actually curious how this could possibly be slower, how anything could possibly be slower than this one. We got this. We even like declare these variables early. I'm wondering like how much does a log actually affect your runtime? Is it considerable? And we can see that they have a similar solution to one of the better solutions. They have the -1 +1 -1. So I'm surprising that this is potentially slower. Okay. And again, this looks like it would be log n. I think the only problem is they have so many conditions. So they first see if the mid is there, then they see if mid's greater than target, and if, ooh. basically they're seeing if if target is between the left and the right value, then they return mid. Then they see if we're basically at the end, then we return mid +1. But they see if they're basically at the beginning, and then they return mid. And then they see if it's greater than, well, okay, all right, interesting. It's okay, it's not, it's also not binary search. They don't cut the problem in half every time. They just increment or decrement left and right. So that's another thing that's gonna make it go slower. Okay, that's just looking at other algorithms. I think I'm gonna move on to another problem.